All right, so just a quick reminder here in Delta Math of what is due, what's been due, and what you can still get late credit for. So this factoring quadratic trinomials when a is greater than 1. This was the new assignment yesterday, assigned on Monday. So it is due tomorrow by midnight for full credit. Okay. Now in the past due tab, if you haven't completed these, you should see them. If you have completed these, they'll show up in the completed tab and you're all good. Okay. There was the most recent was the factoring when a is equal to 1. Okay, so this one was just due last night for full credit. So if you didn't finish it yesterday for full credit, you can still go in and finish what you have left at 80% credit, and that is through the 7th, which is Thursday. So it's open for 80% credit through Thursday, and then it'll drop to 50% credit. Okay, the GCF practice, this is the one where you are inputting the answers. The questions were printed on the back of your notes, okay, and you're inputting your answers. Okay, this was due last week, and it is open at 80% credit through today. Today's the last day at 80% credit. If you wait till tomorrow, it's going to drop to 50% credit. So if you haven't finished that one, go finish that one for 80% credit. And then the factoring pre-assessment now is over, it was assigned over a week ago. Tomorrow is the last day it's available at all, and that's at 50% credit right now. So you've got one more chance at 50% credit through today and tomorrow to get that done. Okay. Anything that is not listed here under upcoming or past due, it is too late to do. I know there are some assignments previous to this. Some of y'all did late work this past week for Unit 5 Part 1 stuff, assignments from before Thanksgiving. I had updated grades that Monday after Thanksgiving last week, and I did not update grades again later in the week. Okay, so I'll be updating those grades, late grades and things again today. So you'll get another update from Skyward, like an email message, once those are all updated again. But I had updated grades at the beginning of last week. Okay, and I know I have several people emailing asking about putting grades in. Remember, I only am required to put grades in once a week, and sometimes that's all I have time for is once a week. So I appreciate your patience with that. When I have time to put them in more often than once a week, I will. But just know once a week is my standard. If it's more often than once a week, that's just a bonus. All right, so those are your current and past due assignments that you can still get done for this current Unit 5 Part 2. So the notes that we're taking today are special factoring patterns notes. Okay, so you can see I went ahead and put at the top here this box that lists all 4 of the special cases that we're looking at today. Okay, so we're going to look at difference of 2 squares, perfect square trinomials, sum of cubes, and difference of cubes. Okay, we're going to do examples with each of these. Okay, and then there's going to be some for you to try at the end to see if you've got the hang of them. Difference of 2 squares is the first one we're going to start with. And this one actually may look familiar because I think y'all talked about difference of squares in Algebra 1. Okay, if not, that's all right. We're relearning it here. So difference, of course, means to subtract. Okay, and 2 tells you how many terms there are. So the difference of 2 squares means you are looking at a binomial because there's 2 terms and it's the subtraction. That's what difference means. So we have it set up as the subtraction of 2 perfect square terms. When that's the case, it will always factor to 2 nearly identical binomials. Okay, you'll take the square root of the first term. So whatever this is, okay, you'll get a, because when you take the square root of the square, that cancels out. So it's the square root of the first term that goes in the first blank of each binomial, and then the square root of the second term, hang on one sec, I don't know what's going on here, is what goes in the second blank of each binomial. And then I said nearly identical. The numbers are going to be the same. What's not identical is the sign in the middle. So one is going to be a plus and one is going to be a minus. So I'm going to go ahead and set up that outcome in all of these in this table. It's going to be 2 binomials, 1 plus and 1 minus. And you can go ahead and set this up in yours as well. I'm going ahead and setting it up so I don't have to keep switching back and forth between all the colors because I'm going to try and get this nice and color coded for you. Okay. So we're going to look at the first term. And we want to know the square root of the first term. So if you need to, on the side, you can always write what you're doing. We're taking the square root of x squared. Not everybody's going to need to do this in their head, though, or need to write this. You're going to be able to do it in your head. What is the square root of x squared? What does the square and the square root operation do to each other there? Those of you on your phones, put them away and let's pay attention. This is a basic question. This is not an Algebra 2 question. What is the square root of x squared? What kind of operations are square and square root? They're opposite operations, so the operations cancel each other out, don't they? So what are you left with? If the square and the square root cancel each other out, what's left? Just x, thank you. The square root of x squared is just x. Okay, so that's what's going to be the first term of each binomial. We get through the notes a lot faster when y'all participate, rather than me just sitting here in silence waiting for somebody to answer a simple question. Then we take the square root of the second number. So the square root of 100. And again, most of you probably won't need to write that down. You will know the square root of 100 is, remember, square root is what you can multiply by itself to get that number. So what do you multiply by itself to get 100? 10. 10 times 10 is 100. All right, so 10 goes in this spot of each binomial. And we had already set up that one is plus and one is minus. That's it. You have factored that perfect square, that difference of two squares. Does that make sense? So we're going to do the same thing again. We already asked ourselves what the square root of x squared is. We said x, so that one we'll just go ahead and fill in. Okay, but now our second term, the term being subtracted, is 36. What is the square root of 36? What times itself gives you 36? 6. If you are struggling with square roots, use Desmos. I did confirm, we discussed it in our last team meeting. You will get the Desmos calculator on this test for the whole test. So if you can't remember the square root of a number, you'll get to just type it in Desmos and find it. Okay, so if you don't know those, you do get to use a calculator. Okay. Also, speaking of calculators, I showed y'all last week when we were factoring the trinomials, I showed you how you could check your answers in Desmos. I said you could type the original expression in the one line and the factored expression in a second line, and then see if they give you the exact same graph. Do y'all remember that? You can do that here. That's how you can check any of your factoring. Okay, your GCF factoring, your trinomial factoring, these special cases. any of them. The factored form should equal the original form when you look at it graphically. They should be equivalent to each other if you factored it correctly. So you can always use Desmos to check your work. All right, this next one, our lead term is not just x squared, it's got a number in front of it, 4. So 4x squared. So I know the square root of x squared is x, but what's the square root of 4? 2. So it's 2x. Because 2x times 2x would give me that 4x squared. All right, what about 121? Does anybody remember the square root of 121? If you don't, you can type it in. Say it again. 11. That's correct. Good. Let's keep trucking here. 16x squared. What would be the square root? 4x. Good. 4x times 4x would give us 16x squared. What about 81? Nine. 9 times 9 is 81. Very good. All right, this next one, some people try to reverse it or switch it. Don't. That minus, it's a term minus another term. We can't switch it. Subtraction, we can't just move the terms around. So our first term is 64. What is the square root of 64? You can use your calculators if you need to. Square root of 64. 8. So that'll be an 8 for the first term of each binomial. And then we already talked about x squared. The square root is just x. So it is 8 plus x, 8 minus x. It is not x plus 8, x minus 8. Okay, the x here is what is being subtracted. So you can't flip that around because that would change that wouldn't be equivalent. All right, let's try 25x squared. What is the square root there? 5x. All right, now this time my second term has another variable, but that's okay because that variable is squared, so I can still take the square root of it. So what would be the square root of 49y squared? 7y. Very good. All right, and then I come down and I look at 8x squared. Is 8 a perfect square? If I tried to take the square root of 8 in my calculator, I get a decimal. It is not a perfect square. Neither is 32. Okay, so that means I can't do this shortcut right the way that it's written. However, looking at that expression, is it 32 divisible by 8? Is 8 a factor of 32? So what does that mean? What's that called when both terms, all the terms have something that they're both divisible by? That is the first type of factoring we practiced. When you're taking out something that they have similar that they can be divided by, what's that called? Nobody remembers the factoring we did last week at the beginning of the week. Look back at your notes. I'm not just going to tell you everything over and over again. Y'all do have to remember things. You're going to be tested on this next week. the very first factoring we started with last week when we came back from Thanksgiving break. Taking out the nobody wants to look at their notes. Y'all want to sit here in silence and waste time. Y'all know the longer notes take, the more class time you have to do the practice, which creates more homework, right? If y'all can't answer what I'm asking right now, you're not going to do well on the test. You should be studying, you should be reviewing your notes. I would get out your notes and read them. When all the terms in an expression have something that they can both or all be divided by, and we can take it out, what are we doing? What is that called? No, we did it before those. Greatest common factor. Thank you. The GCF, they have the greatest common factor. If there is a common factor that can be divided out of everything, you need to do that first. So 8x squared and 32. What is the greatest common factor? What can be divided out of both of those terms? 4 is a common factor, but 8 is the greatest common factor. Greatest implies we want the biggest, because if we just divided out of 4, there would still be a common factor. Okay, so we want the greatest. So the largest number that can be divided out of both of those is 8. So I'm going to take out the 8, and what's that going to leave me with? What will my leftovers be? Good, x squared minus 4. Because remember, what I'm actually doing, if you're still struggling with this, is I'm dividing out the 8. So here the 8 would reduce and be just the x squared. And here 32 divided by 8 is where the 4 came from. Okay, now is that a perfect square in each of these places? X squared and 4? Those are both perfect squares now, aren't they? Yes or no? Yes. All right, so I can take out the GCF, and now I can do my difference of two squares. So over here, I have set up the two binomials. I have to remember to put the GCF that I took out in front though, okay? So that 8 would have to be written in front of those two binomials. So I took out the 8. Now I'm going to do the difference of two squares. What is the square root of x? Yes, excuse me, square root of x squared. It's just x. Okay, and then the square root of 4. Very good. Is 50 a perfect square? Is 18 a perfect square? If you're not sure, you can always, in your calculator in your head, just make yourself a list of perfect squares. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. And you could keep going. Is 50 in that list? No. Is 18? No. Neither of those are perfect squares. but we can see if we can do the same thing we just did on the previous question and see if we can take out a GCF and maybe it will become a difference of 2 squares. So what can 50 and 18 both be divided by? Okay, definitely 2. They're both even. And then if you go through your list of factors to see if there's a greater one, the factors of 18 are obviously 1 and 18, 9 and 2, 6 and 3. And 50 can't be divided by 3 or 6 or 9. So 2 is the greatest common factor. Okay, so we're actually dividing both of these by 2. So when we factor out the 2, what is that going to leave us with? What are our leftovers? It's 18 divided by 2. 9, and then that y squared. So now, are these two terms perfect squares? Now they are. 25 and 9, those are both on my list over there. So I have to put that 2 in front, the GCF. Don't leave off your GCF that you took out. Then what is the square root of 25x squared? 5x, right? And what is the square root of 9y squared? 3y. Okay, so the process of difference of 2 squares is to take the square root of both terms, okay, and then you're creating the nearly identical binomials with those. One is a plus, one is a minus. If you need to, take out a GCF first, and then you may be able to continue factoring. Y'all feel okay about difference of 2 squares? Okay, so the next one listed up here is the perfect square trinomial. Okay, so this one goes, this was a binomial. You had a term minus another term, but now we're going back to a trinomial. Okay, so we've got 3 terms. Okay, and I know this can look kind of confusing. There's 2 possibilities here because it could be a plus for the middle term, or it could be a minus for the middle term. Okay, but either way, what we're looking at, it's going to come out to a perfect binomial squared. Okay, so that means instead of 2 nearly identical binomials where one was plus and one was minus, we're going to get 2 of the exact same. So there's going to be a plus b times a plus b, which we can just write as a plus b squared. Or it's going to be a minus b times a minus b, and we can just write that as a minus b squared. Okay, so we're going to flip over to the back and we're going to practice some of these. I'm going to explain that process to you. Okay, now I realized last class when we went to go do these, when I copied over this equation, it didn't put this as a squared for some reason. So let me fix that real quick. You can rewrite it. That's supposed to be a squared and b squared, not a2 and b2. You can just mark that out on yours to get it written correctly. There we go. All right, so a perfect square trinomial is in this form where the middle term, this middle term, is double the product of the square root of the first and last terms. I know that kind of sounds confusing, but I think once we get the hang of it, once you see it actually worked, it might make a little more sense. So this middle term, we want to be double the product of the square roots of the first and last term. Okay, so the first and last terms we're going to be doing like we did in the previous ones. We're going to take the square root of the first term and the square root of the last term. Okay, what does product mean? when they ask for the product. Right here. Multiply. So we're going to multiply the square roots of the first term and the last term. Well, if the first term is a squared and the last term is b squared, the square roots will be a and b. So we're going to take a times b. And if we double it, what are we doing? What are you multiplying by if you double something? 2. So we want that middle term to be 2 times the product of a and b, is what that's saying. Okay, so I'm going to find the square root of my first term and the square root of my second term. And I'm going to identify those as a and b. Okay, so what is the square root of x squared? X. Okay, so that's just x. Okay, and then what is the square root of 1? Just 1. So here, when we're talking in terms of a and b, it's just x and 1. Okay, so here is how it is written out. I should have written this on the back, but you can go ahead and write that. It's going to be your a plus b squared, if that's a plus sign, or it's going to be a minus b squared, if that's a minus sign, if it fits this, this scenario. Okay, so first let's ask ourselves, is that middle term what we said it should be here? Is it 2 times a times b? So what is a times b here? It's just x, right? Because x times 1 is just x. So is that middle term 2x? It is. So this is that form. So we're good to go. Now the sign there tells us the sign that's going to be in our binomial. It's a minus. So this is going to be a minus. Okay, so the first term is your a, which we just said is x, and the last term is your b, which is just 1. So that is your factored form. It's x minus 1 squared. So we just check that it meets this format, that it meets this rule, and if it does, we can just write a, and then it's going to be a plus or minus b squared. Now, all of these, I just realized, are minus if you go ahead and look at them. So these are all going to be a minus. I don't know why I did that. I obviously wasn't paying attention when I picked out some examples. I should have picked a couple plus, but that's okay. The only difference that it makes is if that's a plus there, it would be a plus here. Okay. All right, so let's try 2. What is the square root of x squared? We just said it, x. Okay, what is the square root of 49? 7. Okay, now we're multiplying, we're asking ourselves in our head, a times b, so 7 times 6 would be, or 7 times x would be 7x. And then we want to know if it's double that, right? Is 14x double 7x? Yes, it is. So this is the perfect square trinomial. So I can just use my shortcut and say, oh, okay, good. It's just going to be x minus 7 squared. If it meets that criteria, we can just use the shortcut every time. Okay, let's try 3. What would my a be? It's the square root of the first term. What's the square root of the first term? 2x. Okay, if y'all need me to keep highlighting, I can. I'm looking at the first term, I'm getting the square root. And then I'm going to look at the last term, and I'm going to take the square root. So what is the square root of 1? 1. Okay, so 2x times 1 is just 2x. Did we double it to get the middle term? Yeah, 2 times 2x is 4x. How about that? So I'm able to use my shortcut and simply say this is 2x minus 1 squared. What is my a going to be in number 4? What's the square root of 9x squared? 3x. Okay, what is the square root of 4? What would 3x times 2 be? 3x times 2. 6x. And we double it. What is double 6x? Hey, that's what we wanted. So this is also a perfect square trinomial. It meets the criteria. So we're able to use the shortcut and just simply say that this is 3x minus 2 squared. Now, if that confuses you, to check that middle term, what I was doing to see if it fits that format. If you're like, I don't know what you just did, that's too much. You don't have to use this. This is a shortcut because it's a special case. If you don't like it, don't do it. This is a trinomial. This is what we spent the majority of last week factoring. Trinomials when a is 1, trinomials when a is greater than 1. You can factor these a different way. You could factor these using what we did last week, guess and check, or the box method, or grouping, where you start with the X method. You're welcome to use those processes here, and you would just end up with writing out both binomials. You would end up with 3x minus 2 and 3x minus 2 again. And that's fine. You get the same answer. You can do it that way. This is simply a shortcut if you make the connection that this is a perfect square trinomial. Does that make sense? Okay. And again, these formulas at the beginning right here, this will be given to you on the test. You do not have to memorize these. You just have to understand what all these A's and B's mean. You have to know what to do with it. But we will give you these formulas. You just need to know how to use them. So far, so good? All right, so the last two that we're going to look at are sum of cubes and difference of cubes. So what that means is sum means to add, difference means to subtract. Okay, so it's binomials again. So if you have a binomial that is the sum of 2 perfect cubes or the difference of 2 perfect cubes, these are how they factor. And again, we'll give you these formulas because it's not something I expect you to memorize. So a perfect cube may not come as easily to you in your head as a perfect square. Okay, y'all are probably more familiar with the square roots than the cube roots. Okay, but a cube root, a perfect cube just means that you can take the cube root and get an integer. Okay, so same thing I did with the perfect squares, how I just like made that list to the side. If that was helpful to you, you can make a list of perfect cubes off to the side. And again, you get your Desmos calculator the whole time. So you'll get to use it to find cube roots if you don't know them. But for the sake of our notes, I will just make a list over here. So 1 cubed, 1 times 1 times 1 is still 1, right? What about 2 cubed? 2 times 2 times 2. What would that be? Oh, 2 times 2 is 4 times 2 again, 8. So 2 cubed is 8. Okay, what about 3 cubed? 3 times 3 times 3. What's 3 times 3? 9. Times 3 again. 27. Okay, 4 times 4 times 4. So 4 times 4 is, and then 16 times 4 be 64. Okay. 5 times 5 is times 5 again. 25 times 5. 125. Okay, so y'all get the idea here. So the numbers get a lot bigger, a lot faster. If you want to list more, you can. Your next one, 6 cubed, is 216. I'll stop there for now, but you can get your cubes by just going through and trying those. You can also get cube roots. So if you didn't know that 125 was 5 cubed and you got to this problem over here and you're like, oh my gosh, I don't know the cube root of 125, you would go to Desmos. I'll remind you where the cube root operation is. So square root shows up on your main keyboard there. If you want a root other than a square root, you'll click on functions and you can scroll down. Oh, it's all the way at the very bottom under number theory. And you can get this root here with has an n, it's the nth root, and you can type in whatever root you want. We want the cube root, so we would type a 3 there. If I want the cube root of 125, there it is, it's 5. Okay, so you can use Desmos to find cube roots of numbers if you're not sure what the cube root is. Okay, you'll feel all right about that? Okay. All right, so in this first one, I definitely am going to pay attention to the sign of these. This one, these two are subtraction, and these last two are addition. Okay, so the only difference here is that where the plus or minus show up in the factored form. Okay, because if it is a sum here of 2 cubes, you're going to start with a sum, but then you're going to have subtraction first in the trinomial. Okay, if it is a difference, you're going to start with a difference and then have a sum first. So it switches those two signs in your factored form. Okay, but the A's and the B's, that all stays the same. Okay, so the numbers aren't going to change. So again, we are going to take, we want to know the cube root of our first term and the cube root of our second term. Okay, so the cube root of 8x cubed would be what? I'm going to write it in here. Yeah, it'd be 2 and then x, right? The cube root of x cubed would just be x. Okay, what about b? What is the cube root of 27? 27 was on my list over here. What's the cube root of 27? What number in the list is that? 3. It was 3 times 3 times 3. It was 3 cubed. So the cube root of 27 is 3. So I've got my A and my B. And now I'm going to write out that factored form. For the difference, it's going to be a minus b as a binomial, and then a squared plus, and then the product of a times b plus, and then b squared. Okay, so I'm going to start with a is 2x, and b is 3. Then I'm going to take, it's a squared. So what is 2x squared? We'll come back to it. And then I'm going to do a times b. So I'm going to do 2x times 3. And then I'm going to do b squared. So that's 3 squared. So now I'm going to simplify that. So the 2x minus 3 doesn't change. What is 2x squared going to become? 4x squared. What's 2x times 3? 6x. And what's 3 squared? 9. So that's the factored form. So we have to identify the cube roots, plug them in there, and then do a little simplifying. Okay, so what is a here in the second one? 125x cubed. What is the cube root of that? 5x. What is the cube root of 8? So I'm going to set this up the same way because it's a difference. Whoa, get out of here. All right, so it's going to be 5x here, 5x squared there, and then b is 2. So that would come out to 5x minus 2 as the binomial, and then 5x squared, that would be 25x squared. 5x times 2 would be 10x, and 2 squared would be 4. So that would be the factored form of that difference of cubes. Okay. All right, y'all are good to go. I'll finish up these last two for the video. There's some at the bottom for y'all to try before tomorrow. So give those a shot. See if you can do some of those. Yep. Yeah, I'm going to finish these two up in the video and I'll post it on Canvas. All right, so for the next two here, it's the same idea, except this time it is the sum. So I'm going to go ahead and write out, it's going to be a plus in the binomial, and then our trinomial will start with a minus. Go ahead and get it set up for both of those. Okay, so then we're going to identify our A. So our first term there. Now, when we did the difference of squares, let me just go back to this right here. And we had a constant and then our term, I told you do not switch those because it would change your answer. That's because it was a minus. If it had been a plus, you can add in any order, 1 plus 2 or 2 plus 1. You get 3 either way. But if you subtract, you would get a different answer, 1 minus 2 or 2 minus 1. So that's why if it's subtraction, you can't change the order. So same thing here with cubes. If it is a difference of cubes, just leave it as it is. Don't touch it. But if it's the sum, you could technically switch those if you wanted to. I don't see any need to, but I just wanted to point out that if it is a sum, you can switch the order. So if it really bothers you having the number, the constant first, and then the variable, technically you could switch that. But I'm just going to stick with the way that it's written. So the cube root of 8 is 2, and the cube root of x to the 6 would be x squared. Okay, because when we're dealing with powers, if you take the root of a power, if it is, you're dividing that power by that number. So the cube root means to divide the power by 3. So 6 divided by 3 is 2. Okay. So now I'm going to plug those numbers in. So my A goes here, and my B's go here, and then I'm going to simplify. So my binomial is just 2 plus x squared, or you could write that as x squared plus 2. It doesn't matter. And then in my trinomial, 2 squared is 4. 2 times x squared is just 2x squared, and that's a minus. And then x squared squared, when you have a power to a power, you multiply those. So that is x to the 4th. Now I'm going to do the same thing for this last one. I'm going to take the cube root of the first term. That is just going to be x, and I can go ahead and plug that in for all my a's. Oh, put that last a in the wrong spot. There we go. Okay, then I'm going to take the cube root of my second term. That's going to be 3, and I'm going to plug that in where all the places that b goes. And now I'm going to simplify. Give me 1 sec, I'm recording. Oh, okay. All right, so that's x plus 3 is the binomial, and then that would simplify to x squared minus 3x, and then 9 squared would, or excuse me, 3 squared would be 9. That's it. So that is your process for factoring the difference or the sum of 2 perfect cubes. Okay, and again, those formulas there, those will be given to you. You just have to know how to apply them. Okay, so I want you to try these, and we'll check them at the beginning of class tomorrow. We'll probably have a little warm-up time, maybe 5 minutes or so for y'all to finish trying these if you didn't get to try them all, or if you didn't end up having time. And then we'll check over them. Okay, but we need to be able to apply these shortcuts or these special cases. These will be on that test next week, as well as the GCF and the quadratic form trinomials we've been doing.